Since the Hyperledger white paper was released, many working groups have been formed. Of those working groups, the Hyperledger Architecture Working Group has defined a layered architecture for various services that we discussed in the last lesson. The initial focus of the group is on the plug-and-play feature of the Hyperledger framework that allows for various members, IBM, Intel, etc., to implement their own version of a specific feature. The pluggability enables an elastic and extensible architecture, distinguishing it from the earlier blockchain designs. The modular design and the permission participation of nodes enable confidentiality, resilience, flexibility, and scalability. A must-read documentation can be found at the link shown. Let's explore the details. On completion of this lesson, you will be able to explain fabric model and its functionality. The fabric model consists of transactions, peers, assets, chain code, ledger, channels, identity, membership, and consensus mechanisms. Here you see an overview of the applications that are enabled by Hyperledger Fabric. You see multiple business blockchains, each with its own channel, with its validating nodes, membership services for identity, and membership management. Interactions between different independent business networks are enabled by confidential smart contracts. Transaction could be inside a single network or cross-network. We'll now examine the various components in detail. Peers are nodes that initiate transactions and maintain the state of the ledger. There are three types of peer nodes. Endorsing peers receive and validate transactions, sign them, and return them to the creating application. They are called endorsers. Ordering peers collect signed transactions, order them into blocks, and send them to committing peers. This is also known as the ordering service. Committing peers receive the blocks created by the ordering service, validate conditions such as double spending and signatures, and then commit them to the ledger. Assets represent the tangible items of value that are transacted on the blockchain. For example, food supply and financial assets. Assets are represented in the program as key value pairs in JSON or binary format. Chain code is a smart contract that defines a set of assets and provides the functions for operating on the assets and changing their states. It also implements application-specific rules and policies. Function execution may result in state changes that are recorded on the ledger. Okay. The ledger is similar to other blockchain ledgers. It is a tamper-proof record of state transitions in the fabric. State changes are affected by the invocations of chain code functions by the transactions initiated by participants on the fabric. Transactions are signed and all the access control rules set by the permission services are enforced for a transaction to be executed and included in a block for recording. Each transaction results in a set of asset pairs that are recorded on the ledger as creates, updates, and deletes. Since a ledger is a key value store, it can be easily queried for later analysis and auditing. Another element of the fabric model is channels. Fabric enforces privacy and confidentiality through the channel concept. Channel defines a single permission network of entities with one single ledger for all its transactions and state changes. channel provides segregated fabric for a group of entities to transact privately. Even within the channel, the data and transaction confidentiality can be achieved by obfuscating and by using cryptographic methods. Channels also provide the ability to support multilateral transactions among competing businesses and regulated industries through cross-chain chain code. In this case, each private business consortium operates on its own private network with cross-chain transaction controlled by policies implemented in the chain code.